Okay, in today's video we'll be going over nomenclature of compounds, IUPAC names, and naming alkanes, alkenes, and alkynes. Also certain rules that apply to naming. So let's get right into it. So first, let's start with a little memorization basically. Okay, so here we have CH4. This is called methane. C2H6, ethane. C3H8, propane. C4H10, butane. C5H12, pentane. C6H14, hexane. Just to save space, C7H16 is heptane, C8H18 octane, C9H20 nonane, and C10H22 decane. So this is a part where you just have to memorize. CH4, methane, has 1 carbon, ethane 2, propane 3, butane 4, pentane, pentagon 5, pentane, hexagon, hexane 6, C6, C7, heptane, octane, C8, 8 carbons. So just go ahead and memorize these, and you can apply it to later examples that we'll see. Okay. Hold on, let me get rid of this. Okay, so let's look at an example. Now, what would be the name of this compound? Well, we see that there's a carbon here. 1, 2, 3, 4, 5, 6. So there are 6 carbons. This structure that we have here is called a line structure. Okay, so what we're going to do is take this line structure, write a condensed formula, and then after that we'll name the compound. So far we have 1, 2, 3, 4, 5, 6. 6 carbons, which is C6. Now, how many hydrogens are there? Oops. Let me go back. Okay, so we said this was C6. Now, how many hydrogens are there? Now, when we see an ending like this here, that there will always have 3 hydrogens. That is called a methyl group, and we'll get more into it later, but for now just know that is a methyl group. At these ends will be 3 hydrogens, and for these carbons in the middle of that we'll have 2 hydrogens. So now if we count that out, remember we have C6. Now how many hydrogens? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's C6H14, and this is your condensed formula. And sometimes what can happen is they'll give you a condensed formula and they want you to write out the line structure, or they give you a line structure and you write out the condensed formula. So from this line structure above, we have this condensed formula. And we agreed that if there's 6 carbons, it is hexane, C6H14. So this compound up here is hexane. Okay, simple enough. Now, let's try another one. What is the name of this compound? Well, we know that we have 1, 2, 3, 4 carbons, C4. And how many hydrogens? We have this end here that has 3, 2 there, and 3 at the end. So we agreed that there were 4 carbons, so we have C4, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. So we agreed that if there's 4 carbons, this would be butane. Okay. Let's go over one more like this. Okay. So again, how many carbons? 1, 2, 3, 4, 5, 6, 7. So we have C7. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. A big number. 8, 16. Agreed that we see 7 carbons. This would be called heptane. Okay. Now, remember, methane, ethane, propane, butane, pentane. Just get that down pat. Just remember, memorize it. Hexane, heptane. Okay. Now we're going into something called substituents. Oh, that's ugly. Substituents. And what are these? They're these special group of atoms that are attached to another atom. Okay, so let's go over them. I'm going to need this long chain to draw them out. Okay, so again, this is memorization. You're going to memorize these, remember them, and then you're going to throw it into one huge concept that you'll see. So this is called a methyl. This is an ethyl. This is just like methane, ethane, propane, except now we're using it as a substituent. Okay? It's this group that's connected to another, attached to another atom. Okay? This here, well, let me make space. Those circles are taking up a lot of space. This here is called propyl. And then here you have butyl. And as you can see, methyl, here at the end there's only 1 carbon. Ethyl, there'd be 2, because remember ethane has 2 carbons, but since we're having as a substituent, it will be ethyl. There's 2 carbons there, 3 carbons here, and 4 butyl. Okay. Now at the end here we have this. This is called iso. Oh man, I don't know what's coming out like that. You rewrite that. Isopropyl. This is isopentane. butyl. Okay. And just for space, let me just redo this. So take a good look at this. I'm going to redo the long chain so I could get the rest to fit in. Okay, so continuing on, we have isopentyl, sec-butyl, this is isopentyl, and this here is tert-butyl. Okay, so far so simple, just a little pure memorization here. Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, methyl, ethyl, propyl, so on and so forth, sec-butyl. Just remember how the structures look, pure memorization at this point. And then what we're going to do is just piece this all together, and that's pretty much it. But so far, just memorize these structures, okay? Now, let's go into some examples. Actually, I wanted to do one more example with the alkanes where they may give you the condensed formula and they want you to draw the line structure. So let's see, they'll probably give you a condensed formula like this. And they want to know, what is the line structure? What is this compound? So you have a CH3, which is a methyl. So it'll be like that. A CH2, another CH2, another CH2, and then the CH3. Remember, think of the CH3 as being an empty end. And in the middle, you have these three CH2s, 1, 2, 3, those CH2s. Okay? So in organic chemistry, they like to shorthand things a lot. Sometimes they'll write the CH3 here, CH3. Other times they won't at all, okay? But you have to kind of assume that they're there. So it'll be like this, CH3, because there's 3 H's there. You have that carbon in the middle. You have 2 hydrogens here, 2 hydrogens here, 2 hydrogens here, and then your 3 hydrogens here. So that is the line structure for this condensed formula. You have your CH3 here, CH2, 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 and your CH3 at the end, okay? So if they ask you, they give you this condensed formula, and they ask you what is the line structure, you'll be prepared. Let's switch gears here and go to something a bit more challenging. We'll continue with the condensed formula thing. This is a very interesting one because they do this a lot. Actually, let me make space because this is a large one. Okay. So oftentimes they'll give you this. This is a condensed formula that they'll give you, and they want to know what is the line structure. But we're prepared. We're prepared for this. So what I like to do is start at this bottom side. You have 3 CH3s. So 1, 2, 3. That accounts for these 3 CH3s there. And in the middle, it's connected to a carbon. So we know that's the carbon there. Okay. And then there's a CH2. It's that CH2. There's another CH2. Another CH2. Another CH2. And let me make that in red, different color for my videos. These are your CH2s. 1, 2, 3. 1, 2, 3. Okay. And now we have, what else do we have here? We have this CH that's connected to 2 CH3s. So we just go boom, boom. And these are your CH3s here that account for these up here. And then in the middle, you have your C. Let me make that in red. You have your C here. And then where's that H? The H is right here. Okay. So that is the structure. That is the line structure. Oh, I dropped my pen. This is the line structure for this compound. Okay. Let's go over some more examples. Let's get into some more naming. Now, I guess we'll stick with the red. Try something new, I guess, right? We have this line structure. What is the name of this structure? Now, here's some rules that we can go over now. For naming, longest chain, smaller series of numbers. Oh man, why'd I put serious? So bad. Move that out the way. Smaller series of numbers, and then 3 is priority, and priority will make a bit more sense later in the video, but right now let's just focus on longest chain, smaller series of numbers. Okay, so what we do is we count out the number of carbons. Go 1, 2, 3, 4, 5, and 6. Okay, so we take the longest chain, and then later we look at what substituents we have. Okay, so first of all, there's 6 carbons, so we know that the parent name is hexane. We have a hexane. Okay, now on number 2, what do we have? We have this methyl on the second carbon. This is called the second carbon here. We have 1, 2, and on the second carbon we have your substituent. What is one of the substituents we went over? Methyl. So how you write that is 2 methyl. Oh, let me make a little space. 2 methyl hexane. And that is the name of this compound. Now, let's check something out here. Now, what if we had counted it this way? 1, 2, 3, 4, 5, and 6. That would be called 5 methyl hexane. But unfortunately, this would be very wrong. You would receive no credit for that on the test. Because remember, look at number 2. It says smaller series of numbers. You want the smallest number. 2 is better than 5. 2-methylhexane. You don't want 5-methylhexane. So you have to take the longest chain of that alkane. Then you have to look at the smaller number. Priority will come a bit later, but other than that, take the lower number. So it'll be 2-methylhexane, not 5-methylhexane. Okay? Let's look at another example. I need a little more space than that. Okay. Oh. Okay. First, let's take the longest chain. 1, 2, 3, 4, 5. Okay. Now, we know that this will be a pentane. Okay. And we see on the second carbon we have a methyl, and on the third carbon we have a methyl. So this would be called 2,3-dimethyl-pentane. Okay. Now, if we were to do it in the reverse, we could have said 1, 2, 3, 4, 5. And this would have been 3, 4 dimethylpentane. But that's not good at all. Why? Because remember, if we looked at our second rule here, that is not the smaller series of numbers. 2, 3, which is better. 2, 3, 3, 4. 2, 3 is a smaller series of numbers, so we take the 2, 3. Okay? So not 3, 4. That would be wrong. Let's take the longest chain, smaller series of numbers. Okay? Let's see. Let's try this one here. Read the name of this compound. Let's count. 1, 2, 3, 4, 5, 6, 7. So we know it is heptane. And what is this substituent here? We went over this. It's your little memorization that I told you guys about. It's isopropyl. And it's on the 4th carbon here. 4th carbon. So this would be called 4-isopropylheptane. Okay? And if we count it the other way, we'd still get the same thing, because this compound is symmetrical. If we count it this way, 1, 2, 3, 4, still end up the same name. Okay? Longest chain is 7. And just to go back on this, if we counted it any other way, 1, 2, 3, 4, 5, 6, 7. If we counted it any other way, say we started here, 1, 2, 3, 4, 5, 6. That's not the longest chain. We could also count it this way, 1, 2, 3, 4, 5, 6. Not the longest chain. It has to be the longest chain. And the longest chain for this compound you saw here was 1, 2, 3, 4, 5, 6, 7. And that's the parent chain we'd go with. Okay? Let's go for another one. So, and another thing too, I guess this is where priority can kind of come through. If you're unsure about which side to start at the side where the substituent is most close to. So you wouldn't want to count this way. You would want to count it this way in the red. 2, 3, 4, 5, 6, 7, 8. Because in this case, you get, where's this on this third carbon, you have this substituent. Remember, it's called tert butyl. So we have 3 tert butyl. How many carbons is the longest chain? 8. Octane. Okay, and even if we did count in the other direction, I'm talking about the white numbers. If we did count in the other direction, we would get 6. Get 6 tert butyl octane. And that would not be good because remember, we want the lowest number. Okay? So start on the side where the substituent is closest to the end. Okay? Alright, let's try another one. This is kind of interesting. This one showed up on a lot of my exams, so. Alright. Thing about this is now we have to find the longest chain. You have to do a lot of counting. Okay, so where do we start? Where should we start? Let's start at the bottom. Okay. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9. Wow, that's a lot of carbons. A lot. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a lot. So a lot of people are satisfied with that. You know, they think that's the longest chain, but we have to keep going. We have to keep counting because there can possibly be a longer chain. So let's start here on this right side to left. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Wow, you see, so the green numbers beat the red numbers. There's more carbons there. This is the longest chain. We thought maybe, okay, 9, we'll just take it. No. This is actually the longest chain. The ones in the green beat out the red. So we're going to go with that, which is decane. There's 10 carbons. Not going to go with nonane, we're going to go with decane. Okay, so now, this is now where we look at the substituents. So we agreed with green. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. On the 5th carbon, what do we have? 1, 2, 3. This substituent is called a propyl. And what do we have on the 8th one? 1, 2. 2 carbons. That is called an ethyl. And now we can piece this together and we have 8 methyl, 5 propyl, decane. And very important, methyl propyl. These substituents you're going to be put in are going to be put in alphabetical order. M becomes before P, so it'll be 8-methyl 5-propyl decane. Okay, let's go over another example. Okay. Let's count it out. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Let's continue to count just in case to be sure. So far we have our longest chain is 8. So far. 1, 2, 3, 4, 5, 6, 7, 8. Well, both of them came out to be 8. So which one do we take? Now, let's start with the red. We'll just start with the red here. Just focus on the red ones for now. Okay. So on the red, on the third carbon, what do we have? We have 2 methyls. Okay. On the 2, 3. On the second carbon, we have another one here. Oh wow, it's kind of orange. Let me put that to red. Okay, that should be better. We have 3 methyls. And let's see what else we have here. On the fourth, we have another methyl. So this would be called 2, 3, 2, 3, 4 methyl octane. Yeah, 2, 3, 4. Okay. Now let us focus on the green numbers that we went along with. 1, 2, 3, 4, 5, 6, 7, and 8. On the fifth one, we have a methyl. On the sixth one, we have 2 methyls. And on the seventh one, we have a methyl. So we have 5, 6, 7, and 2, 3, 4. And if we go back to our second rule, smaller the series of numbers, the better. And that is why we would go with 2, 3, 4 methyl octane. Okay. Let's go to another example. Let's get into alkenes and alkynes. They're kind of the same thing. I mean, not the same thing, but they're pretty similar to alkanes. However, with alkenes, you'll have a double bond, and alkynes, you'll have a triple bond. So let's look at an alkene. Okay. So with alkanes, we had the ane at the end. The ane ending. For alkenes, we'll have the ene ending. So we're experts at this now. Now we have 1 carbon, 2, 3, and 4. So we know that as butane. But since it's an alkene, we need to add that ene at the end. Okay? And we also have double bonds. So we have 1, 2, 3, 4. So from the 1 to 2, we have an alkene. So this will be 1. And then to the 3 to 4, starting at the third carbon, we have the alkene. So this will be 1, 3, bu for butane, buta, and there's 2 alkenes. So it'll be butadiene. Okay. Let's look at another one. So we have 1, 2, 3, 4, 5, 6. We have 6 carbons. So we know hexane. But since it's an alkene, we have that ene. So at the first carbon, at the start of the first carbon, we have an alkene. At the start of the third, we have an alkene. And at the start of the fifth, we have an alkene. So you have 1, 3, 5, hexa, triene, because there's 3 alkenes, 1, 2, 3. So hexa, hexane for the parent name, hexene, double bond, triene, hexatriene. Okay, and that's another thing that I forgot to mention for the alkanes. Let me just a quick example. If you have more than one substituent, it would be tri. So this would be trimethyl, triethyl, dimethyl. Okay. Let's go into another one. Let's do this here. 1, 2, 3, 4, 5, and 6. On the fourth carbon, we have a methyl. Oh, sorry. And from the 1 to the 2 carbon, we have a double bond. So we know that the parent name is hexene, 6 carbons, and it is an alkene compound. Sorry, hexene. So, like we said, at the fourth carbon, we have a methyl, so it'll be 4 methyl 1, because at the first carbon to the second, we have a hexene, so 1 hexene. And other times, you'll see textbooks or tests, don't let it trick you, it's the same thing. They say 4 methyl 1 well, actually it'd be more like this: 4 methyl hex 1 ene. It's the same thing. They're both the same thing. However, I prefer the top one, but other times you'll see they'll write it 4 methyl hex 1 ene. Okay, and for alkynes, it's a bit of the same thing. So I'll show you an example here. The only difference is the ending. We had alkane, A-N-E, alkene, E-N-E. For alkyne, it's just Y-N-E. Okay, so let's count this out. We have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, and remember, best to start on this side here. That's where the alkyne is. So let's count this out. On the 5th carbon, we have a methyl. On the 6th carbon, we have a methyl. Okay, so this would be 5, 6, dimethyl. And starting at the third carbon, we have an alkyne here. Okay, so that would be 3-octine. Okay, very simple. All right, let's go into a bit something that's different. Kind of same thing, but just a different example. All right, what would be the name of this compound? Well, let's count out the carbons. We have 1, 2, 3, 4, 5. Okay. On the second carbon, we have a chlorine, and on the fourth, we have a fluorine. So this would be 2. And for the chlorine, you call it chloro. Okay. And at the fourth one, we have a fluorine, and this would be called fluoro. And remember, it's an alpha order for these as well. Okay. And the parent chain is a pentane. We have 5 carbons. It's the longest chain, so we have 2-chloro, 4-fluoropentane. Okay, let's try this one here. What would be the name of this? So again, we know that we're going to start to the closest side. It should be here. 1, 2, 3, 4, 5, and 6. So we know that this is a hexane. Got the longest chain for 6 carbons. So we have 1. This carbon here it has the chlorine. 1 chloro. At the second carbon, we have a bromine, and that is 2 bromo is what we call it. Hexene. I see a mistake here. If you guys can point out the mistake. Remember, I said alpha order. I put the chlorine before the bromine. So actually, what it would be is 2 bromo, 1 chloro hexane. You guys be careful with that because it does happen a lot. Remember about the alpha order. Bromo before chloro, because B becomes before C. Okay. Let's try this one here. All right, now for this one, let's count this out. So the longest chain is 7 carbons. On the third carbon, we have a fluorine. On the fourth, we have a chlorine. And we have a alkyne going from 6 to 7, the 7th carbon. So let's piece this all together. We have 4 chloro, and remember alpha order. 3 fluoro. 6 hexine. I'm sorry, it's actually hep. So this would be, heptine. Okay. Now, switch gears a bit. What would be the name of this compound? This is called cyclohexane. This is an enclosed alkane, compared to something like this or this. Now we have something that's actually enclosed. It is cyclo. So we'll have cyclo, and then you count up the number of carbons. 1, 2, 3, 4, 5, 6. Cyclohexane. Okay. Now how about this one? What would be the name of this compound? It'd be about the same thing. Cyclo, except we have this double bond here, and we know that's an alkene, so it'll be cyclohexene. Okay. This would be called cyclopropane. 1, 2, 3. 3 carbons and 6 hydrogens. Cyclopropane. Alright. And I think you guys get the gist of things. Now if I wrote it like this, we added a double bond there. That would be cyclopropene. Okay? Fairly simple. A lot of this stuff in this section is just memorization and just getting it down and piecing everything together. Once you get the basis for methyl, propyl, methane, alkynes, propene, and all these names, you just piece everything together, and you should be very successful. Okay, so let's try this one here. Let's add a little spice to it, I guess. What would be the name of this structure? Well, let's see. The double bond gets priority over the atom. So we'd start here. 1, 2, 3, 4, 5, 6. Know that there's 6 carbons, and we have a double bond there, so it's an alkene. So parent name would be hexene, correct? So on the 3rd carbon we have the bromine. You could say 3 bromo cyclohexene. Or the more complicated way that your crazy organic chemistry professors probably will write it just to confuse you. 3 bromo cyclohexene. Either one is correct. Prefer the top one, but you know how Orgo is. They make some things very difficult for you. Okay, let's try a couple of more. How about this one? In this example, where do we start counting? We have 2 substituents here. We have the bromine and the CH3 methyl. Now, we would actually start at the atom. This has priority over the methyl. So when we have our priority check, remember alkynes and alkenes have priority over everything. If there's more than one substituent, alkynes go first. You count off with that. Now, if it's a bromine or a chlorine, fluorine compared to a methyl, start counting at the bromine. So we have 6 carbons, so we know that it's hexane. We're starting at the bromine, so 1 bromo methyl cyclohexane. Okay. How about this one here? Where do we start counting? This substituent has more priority over this. So we're going to start counting here. And go 1, 2, 3, and 4. 4 carbons. So we have a butane parent name. Let's put it in alpha order. And this is called ethyl. So we have 1 ethyl, 2 methyl cyclobutane. All right. Let's go over one where they probably throw in a condensed formula in this here. So let me make more space. Okay, so where would we start counting? Remember, alkenes and alkynes have the most priority. So we can start there. 1, 2, 3, 4, 5. So we know that this is a pen. Remember, it's an alkene, so we say pentene. Now we have to put in alpha order. We know that this is chlorine, this is a methyl, this here C2, CH2, CH2, CH3. What is that? This would be a propyl. It means there's a propyl group that's there. So we have 5 chloro, 2 propyl, 4 methyl cyclopentene. Kind of a long one there. Let me just write it out for you guys. 5 chloro, 2 propyl. See that again. Even I make mistakes sometimes. 5 chloro, 4 methyl, 2 propyl cyclopentene. And why did I switch that methyl and propyl? Because remember, alpha order. M comes before P, C comes before M. Chloromethylpropyl. Okay? Now we'll just go over 2 examples and we'll conclude this video. Okay? Let me draw this over. What is the name of this compound? Okay, so we have 2 enclosed shapes. They're both cyclo. There's 2 of them. So we can automatically call this bicyclo. Bicyclo is what you call it. It's cyclic. Bicyclic. Bicyclo. So now what we do now is we're going to count the number of carbons on each side. I like to call this the 1, 2, 3. So on this side here, we have 1, 2. We have 2 here. How much do we have here? 1, 2, 3, 4. We have 4 here. And we are excluding these carbons here for now. Okay? And at this top, we have 1 right there. So now what we do is we put this in numerical order from descending. So we had 4.2.1. And now we add up the total amount of carbons in the whole compound. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have nonane. So this is called Bicyclo 421 nonane. Okay. Now let's go over this last one. Let me go back a bit, make it a bit better. And just to make it interesting, there. So again, know that there's 2 enclosed shapes. I don't think they'll ever do anything where it's tricyclo, but I haven't seen that at all. This is still bicyclo. Okay. So now again, excluding these carbons here, these are called bridge carbons, by the way. We do not count those. So for this side, we have 1, 2, 3, 4. On this side, we have 2. And then we have 1 carbon up there. So that would be 1. So again, we have we have bicyclo 4, 2, 1. If we count the number of carbons that we have, it totals up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Nonane. Now, we can't forget about the chlorine. So it'd be at the 9th carbon, it is 9 chloro bicyclo 421 nonane. Okay. It's fairly simple to do these naming. You just have to piece everything together. Start with all the alkanes, propane, methane, decane, nonane, heptane. Then from there you go to the substituents, methyl, ethyl, propyl, isopropyl, tert-butyl. Then from there, you can add those together into naming alkanes, alkynes, and alkenes. Then you can add atoms in there like bromine, chlorine. Take priority, longest chain, lowest series of numbers. Then you can go into the cyclos, cyclohexene, cyclohexane, and into the bicyclos and things of that nature. So fairly simple. Just follow those instructions. I'll probably make another video with more nomenclature because I still have to go into alcohols, ketones, naming, aldehydes, things of that nature. But for now, this is the basis of nomenclature. I'll make a separate video of more. This was a long video, but I'll make another one. Alright guys, I hope it helped, and see you next time.